let's say we're taking the limit of the two variable function xy as xy approaches 0, 0 of the function, let's see, x squared y over x squared plus y squared. And for this function, we want to prove that the limit does exist, and we want to prove what the limit value is. So in order to do that, we need to show that for every approach that we take, so for example, if we approach the limit to the origin from this side, let me do a different color. If we approach the limit from the x-axis, we need to show that it is a certain value, and then if we also approach the limit from the y-axis or any other angle, this way, or there's an infinite amount of ways we can approach this. We got to show that all of those limits are equivalent. So that means the limit does exist at this point right here, even though if the function might not be defined. And in this case, the function is not defined, but we want to show that the limit exists. So we're going to do that by using polar coordinates. And I'll explain why we're using polar coordinates afterwards. But for now, we're going to let r equal x cosine theta, and we're going to let x equal r cosine theta, and then we're going to let y equal r sine theta. Now, we know here that if the limit as r goes to 0 of this function, it will make x go to 0 as well. So as r goes to 0, x goes to 0 and y goes to 0. So we can change the limit for this function, rewrite it with the polar coordinates that we just made, and let r go to 0. So let's do that. So we now have the limit as r goes to 0 of, let's see, x squared, so r squared cosine squared, so we'll generate r cosine theta all squared, and then y, so r sine theta over r cosine theta all squared plus r sine theta all squared. Alright, so I'll simplify this a little bit. This is equal to the limit as r goes to 0 of r squared cosine squared theta r sine theta over, let's see, from here we can factor out a cosine squared sine squared, so this becomes r squared times sine squared plus cosine squared theta, and we know that this is a famous trig identity which equals 1, so we can rewrite this whole bottom as just r squared. Now the r squared cancels with the r squared. We notice we still have an r here, so this is equal to the limit as r goes to 0 of just of r cosine squared theta sine theta. Now what this means is that from any angle, so theta would be the angle of us approaching this limit. So if theta equals 90 degrees, that means we're approaching it from the y-axis here. If theta equals 180, we're approaching it from the left side x-axis, and so forth. Now, since we know that cosine theta and sine theta is between plus or minus 1, then we know that if r goes to 0, this limit will be independent of theta. And that's exactly what we wanted to show. We wanted to show the limit as this function goes to 0 is equal to 0 no matter what angle we approach it from. So therefore, this is proven because the limit as r goes to 0 is independent of theta, and that equals 0 times cosine squared theta times sine theta, and that's equal to 0. So we just showed that the limit of this function as x and y both go to 0 is independent of the angle that we approach it at.